So studying for a math quiz or a math test is different than other subjects where you don't just use flashcards and memorize. It's a process. You have to do to study for math. You have to redo stuff and practice stuff. So that's what this sheet is all about. Number one, you're reflecting over the line y equals x. Y equals x is a diagonal line. It goes right through the origin. I already have the point 7, negative 2 on the grid. Remember, you count diagonals. So 1, 2, 3, 4 and a half, 1, 2, 3, 4. And you end up at negative 2, comma 7. The next one I have 8, 5 on the grid, and we're reflecting over the y-axis. So you go over 8 and then over 8 again, and you end up at negative 8, comma 5. With rotations, I plotted negative 4, 3. I put my patty paper over, and I drew the plus sign at the origin. Now I'm going to rotate 90, which is this direction. And that puts me at negative 3, negative 4. All right. Number 4, there's that y equals x again. That is the diagonal line that goes through the origin with a slope of 1. And even though it gives you the point where it landed, negative 2, 10, which would be right here, where did it come from? So you count 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And that's at 10, negative 2. 5 is a reflection in the x-axis, so 8, 3 reflects down to 8, negative 3. Number 6, you're taking the point 6, 5, and you're moving it to the right 3 and down 1. So that puts me at 9, 4. Number 7, you're starting off at negative 8, 3, and you're moving to the left 2 and up none. So you're at negative 10, 3. Now, number 8 says you're rotating about the origin, so I put a plus sign at the origin. And you're going negative 90, which is a right turn. Negative is to the right, and you're doing it one click because it's 90 degrees. So I take the patty paper and I rotate it, and I end up at 7, 2. And number 9, y equals negative x. Y equals negative x is a diagonal line that goes downhill through the origin with a slope of negative 1. The point 5, negative 4 is so close to that line. It's only half a box away, so you go half a box to the other side, and you are at 4, negative 5. It was really close. So y equals x is an uphill line going through the origin with a slope of 1, and the point 6, negative 9 is way over there. So we count diagonals. So it's 1, 2, 3, 4, 5, 6, 7 and a half. And do it again. Half, 1, 2, 3, 4, 5, 6, 7. So that puts me at negative 9, comma 6. Number 11, you're taking the point 3, 2 and you're rotating it to the right 180, although 180 doesn't matter, positive or negative, because you're going to end up in the same place. But right now we're at 3, 2, and after 2 clicks, you end up at negative 3, negative 2. Number 12, I'll just show you mathematically. If you're starting with negative 9, negative 5, you're going to take the x and add 8, and you're going to take the y and add 2, you're going to end up with negative 1, negative 3. Number 13, if I'm taking negative 3, 9, and I'm reflecting it in the line y equals 4. Y equals 4 is a line that cuts through the y-axis at 4. So we go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. You end up at negative 3, negative 1. Remember that y equals x is a diagonal line, number 14. And if the point ended up at 6, 10, and you reflect that over that line, where did it come from? 1, 2, 1, 2, 10, 6. In number 15, I started with 4, -1, and then I drew in the line x equals 7. That's a line that cuts through the x-axis at 7. So I go over 3 more, and I land at 10, -1. Number 16, I plotted the point -2, 8, which is this point, and I'm going to move it to the left 5 and down 1. That puts me at -7, 7. In number 17, I have the point 5, 6, and I'm going to rotate it 180, which is to the left. So 1 click, 2 clicks, and I end up with the point -5, -6. 18, 3, -2 is plotted. Plus sign is on the origin. I'm going to rotate 3 clicks to the left because that's 270. So 190, 2, 180, and 3, which puts me at -2, -3. Number 19, you're starting here, you're doing this, and you're ending here. So it's like step 1, step 2, step 3. So I'm starting at -3, 7, and then I'm going to subtract 6 from the x, and then I'm going to subtract 3 from the y. You end up at -9, 4. But in question B, if I landed at 5, -4, after having been raised 6, I must have started at -1, because -1 plus 6 is 5. And I must have started at -10, because -10 and then a rise of 6 puts me at the -4. So once you think you're right, take this point and check and see if that translation results in that. You could use real graph paper, or I just sketched one there. If you had 5, -2, and then -5, 2, actually a rotation of 180 or a reflection through the origin, I'm not very concerned with that one. In number 21, you have the points 4, -1, and -2, -1. I'm going to go up here and plot 4, -1, and -2, -1. And you'll see that the line of reflection had to be right in the middle, 3 from each side, which is the line cuts through the x at 1. So it was the line cuts through the x at 1. The next one, -3, -6, and 3, -6. -3, -6, and 3, -6. That looks like it's right down the y-axis. You could say x equals 0, or you could call it the y-axis. So number 23 is a little puzzle. You have -5, 7, and it ended up rotating onto -7, -5. So what was the rotation? I already have it plotted here. Here's where it tells you it started, and here's where it told you it landed. If you want to test it, put your patty paper on. And my hunch is that this is going to be a 90 to the left, and look what happens. When you turn it 1 click to the left, it lines right up. And 1 click to the left is 90 degrees positive. So it was a rotation about the origin of 90. 24, you have to get used to this saying. It says that something is the image after rotating. Explain why it's congruent. And it's congruent because a rotation, which it told us it was, is a rigid motion. And rigid motions preserve distance and angles, which is why it's congruent. So if it's asking you to say why is it congruent after something's been rotated, reflected, or translated, you say it's because all of those things are rigid motions and those things preserve distance and angles. in number 25, which one is not a rigid motion or an isometric transformation? Which one's not rigid? The only one that changes size is a dilation. Reflections, rotations, and this translation vector all stay rigid, but the dilation does not. And the last one, you're reflecting over the line x equals 7. That cuts through the x-axis at 7, which means this might not fit on the graph, but we'll figure out where it goes. Here's the original, A, C, and B. How far do I have to move C to get to the line of symmetry here? 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have to go 9 more from 7, which is going to put me at 16. So it's going to be 16, negative 3. So C double prime is 16, negative 3. Now, A prime is going to be 3 further than that, right? Because I went 3 further this way, so I'm going to go 3 further this way, which would be 19, comma, negative 3. And then B is right above A, so it has to go 12 and then 12 more, which puts it at 19, but comma, positive 3. So even though we ran out of graph paper, you can count and figure out how far over it would be. Pause this video, go back. If you can do all of these, you will do awesome on the quiz.